everyone. It's great to see that so many people have logged in to watch this webinar. It is a live webinar and we will have time for questions and answers at the end. So feel free to pop your questions in the Q&A chat window and I'll make sure to monitor that and we'll throw those questions to Joe at the end. This webinar will also be put online, so on YouTube, so you can watch it over and over again if you want to. So welcome to all of those who are connecting in, watching this later as well on YouTube. So without further ado, I will give an introduction to our speaker of the day. And it's really my great pleasure to introduce Joe Abley. Joe Abley is the CTO of PIR, the Public Interest Registry for the .org domain. Joe has spent the last 20 years working with internet infrastructure in many parts of the world, including satellites and undersea cables, backbone and access networks, and the domain name system. He has a nuanced understanding of the internet at a detailed technical level and a pragmatic appreciation of the needs of service providers and the end users that depend on them. Joe is an active contributor to efforts promoting technology education in developing regions and a long-standing participant in standards bodies and technical operator communities. A long history of involvement with infrastructure development and technical capacity building globally has helped build a worldwide personal network of colleagues in unusual places. And I should also add that Joe is also a very good friend of mine. He's got the most excellent accent out of all the people I know in the industry. I don't know if I'm placed in one of these unusual places, but I think an example of one of these good friendships that he's forged over the many years that he's worked all over the world. So without further ado, I will give the floor over to Joe, who will present new symbols, new people, new names, a curated playlist of possible futures for our collective use of names on the internet. Over to you, Joe.
Thank you, Narani. I presume someone's going to tell me if I'm on mute. Nobody has, that's good. So I will say a couple of things before I start. First of all, I've never heard that bio actually read out before, and it sounds unbelievably pompous, and I'm sorry about that. And the second thing is to introduce the character that's on the screen right now. This is my daughter from a couple years ago. She is my research assistant. She's telling me about the future. I'm not usually in the business of talking about things that haven't happened yet. I usually talk about things that have happened or are about to happen. So suggesting that I should talk about something in the future was a bit new. So, you know, I need to consult a young person because young people actually know what the internet is for, even if they don't know how it works. So having just introduced her as my research assistant, I should now be very clear that she has in fact in no way contributed towards this presentation because something happened in the last 2 years and I became desperately uncool. And so I'm quite sure even without asking that she'd have nothing to do with it. But I imagine that these are the kinds of things that she would come up with if she was, you know, suitably inclined to talk to me. So here we go. What are names for? We can't really talk about names in the future without really understanding what they are. So I imagine this tangle of possible themes and ideas, this word soup, the idea that names might have come from the point for the application of trying to make it easier to find things on the internet because humans can't remember numbers. Names are easier to remember, but really that's the version of reality that we give, the version of history that we give in workshops and tutorials. Is it real today? Does it actually mean anything? The DNS is kind of ingrained. It's domain names are ingrained, and not just in the perspective of trying to avoid remembering an IP address. We choose names that are easy to remember. There are companies that are now named. The company names are named after the domain names. Part of naming anything, any product, is looking up the domain names first and making sure that they are available. If they're not available, they don't conflict badly. People's brands are tied up in their domain names. These names on the internet are attached to kind of everything. Numbers are attached to names. Names are attached to numbers. And then weirdly, they're so ubiquitous that no one really knows what they are. If you talk to an average person and ask them what an IP address is, it's something they might have heard about because they had a pop-up telling them something unhelpful on their desktop, telling them that something's being blocked or in movies where IP addresses are being traced, but nobody really knows what an IP address is. It's just some fictional thing that exists in the world. People don't really know what domain names are, I don't think. I mean, people know, they recognize them, they use them, they're part of the vocabulary, but most people don't know what they are. Most people don't register them. Most people don't realize they can register them, or why they would register them. So what does all this mean? And in particular, what does it mean when the way that we engage with the internet is decreasingly on the desktop or even on the laptop? It's on an iPad, it's on a phone, it's on a watch. What do domain names mean on a watch? Phone numbers still exist. We can still make phone calls, but I mean, the word phone is almost an anachronism. I forget my phone can make phone calls. So we have these bits of technology. Is a domain name like a phone? Is it like a phone number? Years ago, when Harriet was much smaller, she was, I think, 6, and I went into her school and I gave a little presentation about, it was one of those things where the firemen came in and talked about putting out fires, and the nurse came in and talked about fixing people. And I went in there and talked about the internet, and I had slides showing cables draped down roads and bits of fiber optic cable, and there were just blank stares because none of this means anything to anybody. You ask people, what is the internet? And the kids in the room were saying, well, it's on the screen. Because the idea of a computer that doesn't have the internet is just a broken computer. So the internet is the computer, which means the internet is the phone. But the internet's also work, it's school, it's friends, it's services. Services, what are services? I suppose services are apps. If you're used to phones, apps, what are apps? They're content. Internet is content. Everything is content. So what is a domain name? I think domain names are infrastructure. I was going to say damn here, which I thought would be amusing, but then I thought nobody would hear me or react. So I've done it anyway now, haven't I? So that's terrible. Domain names are infrastructure. What does that mean? What is infrastructure? What other infrastructures do we have on the internet? So the internet came from a place where the network looked very different. We had a provisioning system for voice calls on the internet that was measured in Erlangs, and Erlangs kind of corresponded to full use of a time slot over an hour. And you would use this in order to provision international cables or numbers of T1s or E1s between exchange points. The picture here is the original central office, which is the North American word for telephone exchange, in Toronto. It's actually the original one in Canada, I believe. And it's at 151 Front Street. And this is now the site of the internet, the Toronto Internet Exchange. So I like that picture because even though it's a faceless, awful building, sort of a carbuncle, as you might once have called it, it kind of represents the change between telephones and the internet. Because the internet used to be something that you used over the phone network. It used to be something that you connected computers together with using modems, sometimes leased lines that were really repurposed from time slots and voice calls. And in a similar sort of way, teletext was a text service, a news service that was based on television, that we had this frame blanking interval as the cathode ray tube, the magnets pulled the beam back up from one corner to the other. And during that time, there was just dead air, so you could transmit something. So you could translate teletext. So teletext is a niche service that runs on top of television. SMS was a niche service that runs over GSM signaling channels. It wasn't necessarily a service that anybody would use. Enterprise networks were fast. Like I remember trying to rebuild a corporate network at a phone company in New Zealand in the late 90s. And the internet was the part of the network where you could actually turn on debug IP packet all over a serial link, and it would actually be readable. You wouldn't crash everything. You couldn't do that on the LAN. The LAN was fast. The internet was slow. And then slowly we get to this point with the standard internet graph up and to the right, where suddenly this all turns around. The enterprise network is slow, the internet is fast. The voice network is now just an application that runs over the internet. Like I said before, phones make voice calls, and you have to remind yourself that that's true. Sometimes you can't join a call and have to be reminded that you can dial into it like a conference bridge, like it's making a call from the past. Television is a niche service that now runs over the internet. The teletext that was in the frame blanking interval is now the massive sort of volume of text that goes along with it, flows around the video that fills the internet. And just recently, there's an undersea cable about to go be lit next year, the year after next, the Grace Hopper cable. There's two interesting things about this. First of all, it's a private cable. So this is a LAN that now extends under oceans. And it's advertised in the press as being measured in capacity at terabytes per second. I mean, these are big numbers. There was a time when half of New Zealand hung off 2 E1s, 2 MCI half-circuit leases, and those days are long since gone. So the network has changed. The network has turned around. What used to be basic network infrastructure is now apps, services. What used to be apps on top or services on top, niche things that occasional people used, is now fundamental to how all kinds of things happen. So this is the network. This is not names. Why are we talking about the network? Well, I think we have a much better picture of how the network has evolved, and we have a much weaker picture of how names have evolved. So the bottom right, again, is a diagram that we see in every DNS tutorial, every DNS workshop that has ever been held in the history of DNS. And it shows a stub resolver, which we imagine being an operating system, being talked to by applications, and it's sending queries to a resolver, and the resolver is sending queries to root servers. And this looks very simple and straightforward. You can fit it on one slide. This describes the entire process by which names are resolved. Just like that routing diagram there shows exactly how routing works on the internet. And I chose this exact routing diagram very carefully because I want to be the person that put RIP and IGRP on a slide at a LINX event. So there you go, someone's done that now. You're welcome. So in fact, the routing is not that simple, is it? I mean, people who have joined this call probably realize that. The business of moving packets around the network is far more complicated than even that simple diagram would suggest. It's, you know, it's even if you fill in the correct names of the modern protocols, an address is not necessarily the same address somewhere else. The view of the internet depends on where you send the packet from. Sometimes this is obvious because you have private use networks in the obvious places. Sometimes it's not obvious. Sometimes you've got multiple layers of address translation. We've got deep packet inspection. We've got packets being redirected to places other than their destination address, other than where the routing system would tell them to go. We've got devices that can't join the network or can join the network and require extra protocol support to do that. We've got firewalls. We've got ports that are always blocked, ports that are now blocked forever because they were once abused and can never really be opened up again. Otherwise, the virus that once afflicted and exploited the holes in the ancient windows will suddenly come back to life and start flowing around the network. We've got host-based firewalls. We've got site-based firewalls. I presume we have app-based firewalls, but we're not saying that yet. We've got routing loops, routing leaks, routing hijacks. We've got V4, V6. We've got overlay networks. We've got VPNs on top of VPNs on top of overlay networks. We've got origin attestations. And what this all boils down to is the routing system is complicated. It's really quite complicated. You have to know a lot about how the internet works to try and make this stuff happen. And when things go badly wrong, you have to try and work out why. And it's not easy. So again, this is moving packets. This is not names. So names are not as complicated as this, you might imagine naively. But in fact, names have got ridiculous amounts of complexity in them. And the scary thing about names is how little this complexity is understood. The proxies, the forwarders, the fact that the server you're sending your query to that is responding might be different for different people. You've got anycast distribution of name servers. We've got resolvers that seem like they do simple things, except not all resolvers return the same answers. Some support private namespaces, some block certain names, some don't. We've got centralized name servers. We've got Quad 1, Quad 8, Quad 9. I mentioned to someone the other day that we're going to get Quad 10 soon, and they were excited. And so I just let them be excited. It's fair enough. And all of these things have to mix with the actual business of the internet because the names are not an end to themselves. Nobody just deploys names for the fun of doing names. Some people do. Normal people don't. And so we need some way of steering traffic towards particular end users or choosing content that's appropriate for particular end users, even though the queries themselves are mediated through proxies, forwarders, centralized resolvers. So we have an EDNS 0 option to give its client EDNS 0 client subnet, which is really just a way of leaking the identity of an end station right through a resolver network to an authority server, with all the sort of scary privacy implications that suggests. We got DNS that's being hijacked in airports and cafes in order to display splash screens asking you to confirm that you've read, terms and conditions that you haven't read. We've got private namespaces. We've got all kinds of queries that arrive at the root, the DNS, that don't correspond to any TLD that is actually delegated. These things are all configured separately. Private namespaces, queries leaking out, So the DNS is not the same in different places. The DNS depends on where your resolution infrastructure lives. We've got multicast DNS. We've got .local, for example, which is the anchor for multicast DNS. So some names in the namespace use the DNS, some use different protocols, because multicast DNS got DNS in the name, but it's not DNS. We've now got new GTLDs. We've got thousands of top-level domains, some of which are barely used, some of which are used a lot. You know, some of which are really sort of a challenge to use because there are assumptions based into software and also into people's minds about whether an email address that ends in .guitar is really an email address. We've got service discovery. We've got DNSSEC, glorious DNSSEC. DNSSEC will save everything. It will avoid the corrupted cache. It will allow attestations as to the validity. And it secures the DNS right down to the point where you can validate it, which is not the application. And then the last mile, sometimes from the other side of the internet, is completely insecure. So DNSSEC has issues in its deployment. DNSSEC involves key rollovers. You may remember a multi-year exercise recently where changing the key that's used to sign a particular resource record set in the root zone took years. Because there are trust anchor distribution problems, and that makes DNS more complicated. There are response sizes that, when they're too large, cause responses to suddenly get dropped silently, causing all kinds of applications to have to retry. We've got TTLs set to 0, which means that this thing should never live in a cache. And when the caches keep them anyway, you've got names that only exist and are only used once. We've got people who set maximum TTLs and minimum TTLs, and they ignore what was intended by the application or the service provider, and they do their own thing to protect their own infrastructure. And some of these names that are used once to defeat caches just circulate forever. Jeff Houston has found examples of queries that he sent exactly once in response, and a response that's generated exactly once. And these things just circulate on the internet like background radiation. And more recently, this stuff started to become a little bit more mainstream in terms of people's pitchforks waving and tar being poured down from ramparts, and suddenly DNS over TLS and DNS over HTTPS threatened to provide, to disrupt the sort of the control that an ISP or a network provider can exercise over the traffic. This is disrupting the idea of the DNS as a control plane, the DNS as a way of stopping clients from looking up names that might do them harm. DNS over TLS was one thing. DNS over HTTPS was quite another thing, because suddenly you can't really block it. Everything runs over HTTPS. If you block all HTTPS, you block everything, and then there's no internet, so you can't do that. So how do you block things? Mixed into all of this stuff, these last two are really sort of facets of enterprise DNS. And these are the things in particular I'd like to talk about in a bit more detail. So enterprise DNS, since as long as the enterprise DNS has been a thing, have really measured themselves by round trip times, and they offer SLAs based on round trip times. So they will say that every query that you send to their infrastructure for a name that's your name that you're paying them to host will trigger a response within a certain number of milliseconds, no matter where you are. And infrastructure is built out around the world to support this. And it's kind of a feat of engineering that they managed to do this at all, because at the same time as trying to maintain these SLAs, they're also doing a ridiculous amount of real-time, response time processing on the queries that arrive. So on top of all the rest of the complexity in the actual protocol, we've got all this extra engineering that happens on the edge. So at Dyn, when I was at Dyn, when Dyn still existed, we called these stupid DNS tricks, and that was actually a technical term. And the stupid DNS tricks, things that you would do in between receiving a query and generating a response, that were the secret sauce that was added on, and this was the enterprise component of the DNS service. And effectively, what this is all about is trying to optimize the performance of applications that are increasingly dependent on the DNS. So you have someone using a browser and of some kind, and that browser is using the DNS, and the browser ultimately is using the DNS to try and find content, which is stored in some sort of content distribution network. And if you get that wrong, if you choose the wrong content distribution network, the experience for the user in their application in the browser is ridiculously bad. And if you choose it very well, it's ridiculously fast. So the difference between ridiculously bad and ridiculously fast is money. And that's why these services exist. And they exist despite the fact that the DNS is really not suited to making these kinds of decisions and being used as a control plane for traffic like this. So what happens is, the only information you have as a DNS server when you receive a query from somebody is the query itself and where it came from. So you know what someone's looking for, but you don't really know where they are. You have to guess. So sometimes we have things like eDNS client subnet, other times we don't. And the way you make this kind of determination, this inference of location, is to look at the exit address of the resolver that sent you the query, the last resolver in the chain of resolvers and forwarders that sends a query towards an authoritative DNS server. And that authoritative DNS server then has to use that information to try and infer a location, ideally a provider-city pair. And with that inference, look up a particular tailored response that would make sense for a user using that provider in that city, and then send it back to them within a very small 2-digit number of milliseconds. So you build that mapping and build that inference engine about where the location is based on real user monitoring. So these services are fed by streams of data that come from end users, real end users in real places. Usually JavaScript bugs installed in people's web pages, constantly trying to update this mapping of where the user is and what the performance is, relatively speaking, to different CDNs at different times of day. And it's very, very complicated. All of this stuff is happening alongside the services that are actually being run. All this stuff is trying to just engineer a client being able to talk to the content that's most suitably located for that particular browser, that particular application. That's a lot. That's a ridiculous amount of engineering, and it's all shoehorned into the DNS. So what are these browsers? How many browsers are there? I like this slide because I've got a slide here with 5 things and 2 browsers. That's a topical joke for us there. We can laugh at the browsers that are not there anymore. Maybe there's 3. Maybe I'm being unfair to Opera. But anyway, how many browsers are there? There's generally not many. We look at these market share, and you see WebKit has a certain popularity because it's used on iPhones and iPads, and Chrome has an enormous market share. And you think, well, okay, the market is heavily weighted towards Chrome. So, but there's other browsers there as well. So we have a few browsers. So we don't have that many browsers, we have some. And I think that's the wrong answer. I don't think we have 2 browsers, because I think each one of these things is a browser. Each one of these is a piece of software that an end user interacts with. Almost all of these here in this example, this is my phone. I should have checked there wasn't anything embarrassing in there. But this is my phone. All of these things are browsers in some way. They all use HTTPS, they use REST, they're making HTTPS queries, they're looking up names. Each one of these things is a browser. There's 2.2 million of them on the Apple App Store. There's 2.8 million on the Google Play Store. That's 5 million browsers. So how many browsers do we have? We have 5,000,002. And on 2 of those browsers, the domain names are actually exposed to humans because you actually get to type them in. And in 5 million of those browsers, they're not. I mean, this is not, counting by browsers doesn't necessarily suggest that the ratio of traffic that's generated where the human is aware of the domain name is at the ratio of 5,000,002 to 2. I mean, I'm not suggesting that for a second. But there are a lot of cases where the end user is using a browser and has no concept of the domain name that's involved. And all of those domain name lookups happen in the background with all of that extra infrastructure trying to optimize the delivery of content towards those particular kinds of browsers. And even with the general purpose browsers, with the Chromes and the Safaris and the Chromes and the Safaris, you ask yourself, is a web page an application or is it a website? I mean, how many queries are generated by a modern web page just in the course of scrolling down the page? And it turns out the answer is a lot. Back in the pre-COVID times, I'm going to think it was about 9 COVID years ago, there was an internet symposium that ICANN put on in Bangkok, attached to a global domains division meeting, I think. And Dave Dagan was there, and he gave a presentation. And one of the most interesting things to me, anyway, that he mentioned, he talked a lot about eDNS client subnet and what he saw in the world and how this was bad for privacy, and that was all interesting too. But he mentioned that the resolver infrastructure, the DNS resolver infrastructure on the campus network at Georgia Tech was already running so close to capacity that it looked like it couldn't support a second Facebook. So if Georgia Tech is typical, that means that the internet can only really contain one Facebook. That's just because of the load of DNS queries. And I feel like there's something wrong with this. This model doesn't seem to add up. It doesn't seem to scale. You don't imagine that Facebook is the only company that could ever provide social media of the kind that Facebook does. But what if the infrastructure just won't support another application, another service in a browser or an app of Facebook scale, because just the naming system won't support it? I mean, that's quite a dramatic statement. And the DNS is not without money. It's not like all of this stuff is happening without investment. We have an enormous amount of investment around organizations like ICANN, which pulls in, if you count the hours that people put into ICANN, it's an enormous dedication of funds. There are TLD registries like us. There are registrars. There are resellers of registrars. There are DNS hosting companies. There are enterprise DNS hosting companies, email services, brand protection services, anti-spam services, technical abuse, threat intelligence services. And all of this entire investment is really centered around the idea of producing names and maintaining names that are useful for humans. And yet we've got 5 million browsers potentially that are not exposing those domain names to users at all. So how does this add up? How much of the network is being designed for names that are human readable, when in fact the resolution is not actually happening by humans at all? So if we imagine that these robots are looking up a substantial number of names on the internet, and that the overhead involved in getting those names and the services attached to those robots to work efficiently is high, is it worth doing? Is it worth trying to have one resolution system that does all of this stuff together? Are there compromises here that we're inheriting and scaling problems just by the fact that we're not separating them? Do robots have the same needs as humans? So what do humans need in terms of names? It's a good question, isn't it? I mean, there's one way of looking at it, I think, is to try and imagine how you would go and find out information about someone. If you want to know what Donald Trump is saying, if you do, lots of people do apparently, then how do you do it? Do you go to his webpage? Do you go look at his blog? No, you go to Twitter. And if you go to Twitter, are you looking for a Donald Trump domain name? No, you're looking for a Twitter handle. If you're looking for musicians, then you're looking on, where are you looking? Are you looking on Spotify, or are you looking for web pages? You might be looking on web pages, but quite often I think you're not looking at something with a domain name. You're looking them up with some other kind of name. Diplomats tweet, actors tweet, philosophers tweet, authors tweet. Twitter is almost more important in terms of finding particular kinds of resources than the rest of the internet put together. And none of those things use domain names. There's one, twitter.com. The rest of them are all a namespace inside the application. However, what about companies? I think it's reasonable to say that there are lots of companies you can interact with using apps, but there's also lots of companies that you expect to be able to go to using a domain name. And maybe you use the domain names in different ways according to how you're trying to interact with the company. Maybe when you're looking for products or you're trying to buy something, you might have one way of trying to interact with the company. If you're trying to get support, you might have a different way. I mean, support is perhaps not the best example, because support seems to be more or less instantaneous on Twitter, and then by email, you get a response saying, well, look at your email sometime in the next 9 weeks, and they don't. But I think it's fair to say that interacting with some of these things requires domain names, even if not all of them require domain names. And the domain names need to be, I guess, semantically relevant. What about robots? What kind of names do robots need? Robots don't need semantic meaning in their names. They don't need names that stick around forever. They don't need names to be sticky. They don't need to remember names. They don't necessarily even need names to be globally unique, depending on how they're used. So when an app is talking to a service provider, and the app and the service at the back end is provided by the same company, then you can kind of do what you want. You don't need to, you're not exposing domain names to humans. You're using names as a layer of indirection. You can do whatever makes sense for you. You don't even need to use names, although most people do, because the layer of indirection is useful. But when it comes down to it, you're only trying to interoperate with yourself. When you're using a name for a human, you're trying to interoperate amongst different people, different services. You have different software that's used, and you have a requirement to interop. You need some sort of standard understanding of how the names work. You don't need that to your robot. So where's all this going then? Well, I'm going to choose one thing. I think my my little précis for this talk, which I was just suggesting as an idea, which I realize has been pasted right verbatim right into the meeting invitation, may not steer exactly the same way as these slides, but I'm going to take aim at that stupid DNS trick that I illustrated before. This idea of all this real-time processing going on in order to try and steer responses or steer clients, browsers, towards particular resources using the DNS. And I'm going to say something that is going to, I don't know, certainly some people think this is horrendous, and this is the most evil thing they've ever seen since the last evil thing they saw. Paul Vixie has a great presentation where he describes the great evil of all of this around the DNS, centered around his networks, his rules, and how he expects as a network operator to be able to take control over his traffic, and that includes the DNS. He gave that talk at NANOG in Austin last year, I think it was last year. And anyway, resolverless DNS is a concept that's come up, but it's kind of got pushed to the side, and it's become toxic because it involves HTTPS. And DNS over HTTPS, or DOE, is this turned into this flame war where the tension between control and privacy flared right up, and unsurprisingly doesn't have a simple solution because they're both opposites and they're both desirable. So what is resolverless DNS? Well, resolverless DNS takes the transport for DOE, but instead of applying it between the application and the resolver, it actually moves the resolution right inside the HTTPS bundles that are being used to shift content around. So when an application, it calls out with the REST call to try and retrieve some piece of content from some remote server, it uses the DNS to set up the HTTP session. But then within the HTTP session, there's no reason why you can't exchange DNS queries and responses exactly as additional objects inside those transport layers and not use the DNS at all. And this moves all the DNS resolution for a particular application, just for a particular application, right alongside and interweaves it with the content. So the content's in one place. The DNS lookups are in exactly the same place. And suddenly we could imagine doing testing from the application itself to try and work out where the content is, passing that telemetry backwards and forwards within the security perimeter already established for those HTTPS bundles, and then correspondingly passing the names to give that layer of indirection to allow the content to be reached. So it kind of solves the massive engineering effort that goes into the stupid DNS tricks by loading the application indirection layer into the application traffic, and it keeps it in the same place. One of the common complaints about this and the fear of this is hiding all this resolution would somehow introduce new attack vectors, new security problems. And of course, that's all possible, entirely plausible. Until you look for security problems, you don't know what you're going to find. But I think one of the things that's interesting about it is you can look at this and say, well, this is very operationally complicated. How do you debug this? But then you look at the equivalent system that's actually deployed in the real world with these stupid DNS tricks. And that's about the most operationally complicated thing you've ever seen. And trying to debug that, trying to work out why one particular person in one house has a service that's slow and the person in the next house has a service that's fast, and watch the difference between them, is really, really difficult. It all depends on all kinds of factors which are just not visible to the service operator. Whereas this way, the resolution and the application data is combined together. The application author, the service provider, controls it all. So I think this is quite interesting. And the nice thing about it is that the infrastructure for it is kind of already there. And the question of will we see it be deployed, another way of looking at the same question is how would we tell if it is deployed or it's not deployed? These are all inside HTTPS bundles between applications and services that are run by individual companies. And nobody else gets to peek inside and see what's there. Maybe it's already happening. How would we tell? So do we need domain names? This is not, do we need the DNS? I think the DNS as the resolution system is different from the namespace. Do we need domain names? Is the namespace still useful? And I think it's pretty clear that it is. I think it's tempting to look at the vast array of apps and the prevalence of particular social media sites and artists who are taking their names as their YouTube handles and imagine that domain names are no longer relevant anymore. And yet they kind of are. I mean, I said, I thought very cleverly to somebody a long time ago, who would have ever thought that the spam problem would be solved by nobody under the age of 20 using email anymore? Which is, I think, a very clever thing to say, but I don't think it's true. It turns out that services like Yahoo have email loads that go up through the ceiling and continue to climb, and they're not declining, and people are not using less email. And it's actually a fiction to imagine that young people are not using email. I think they're just using it in different ways. So the other question I think which needs to be asked, because I've mentioned the word browser an awful lot, and the web and HTTPS. And of course, we know the internet is more than just the web, more than just HTTPS, more than just browsers. But browsers do tend to be the main thing that introduce domain names to end users. Email is another clear example. But does it matter? I mean, if the web is a good enough example, if it's putting enough strain on the DNS system, isn't this reason enough to be able to consider whether human readable names and machine readable names could actually be separated, and what that might give us? So I gave this talk the name that it has based on this quote from Jim Morrison, which, to be honest, I just got by Googling for quote name and seeing what came up. But I thought this was quite nice. And I liked it very much in the context of my daughter, coming back to the very beginning and looking at her standing there and using the internet in new ways and really teaching me what the internet is for rather than how it works. And she's, in fact, you know, she's even better example than I thought, because she's actually changed the name now. She's decided she doesn't want to be called Harriet anymore. She wants to be called Hattie. So it's a perfect example for that quote. And you know, and it turns out that even when you're young, even when you're finding out new ways to use the internet and molding this tool, this communications fabric to what makes sense for you as a young person, growing up, never having known a world where the internet doesn't exist, as you still find things every now and then that are old, that seem new again, things that you thought would be disappearing come back. The other day, Hattie sent me a message. I got a notification on Telegram that Hattie has just joined this brand new service that she just found out about called Telegram. And she was kind of horrified to find out that not only had I known about it, but I've had an account on it for a very long time. And that was her response, which is typical. And my other example is an article that I read in Rolling Stone last year, where for the first time vinyl is poised to outsell CDs, which has never happened before never happened since 1986. Sometimes it doesn't matter why things come around again, but sometimes they do. And I think domain names perhaps can fall into the same sort of category. The domain name system has evolved far beyond the original goal, which is trying to give people names to remember instead of IP addresses. And in the process, it's accumulated an enormous amount of baggage. Caches don't work the same way as they used to. DNSSEC is difficult to deploy because we have these stupid DNS tricks with response time answers. Caches are filled with ephemeral names from Facebook. We have names that circle the earth and never seem to stop. And perhaps we just don't need that anymore. Perhaps we can go back to basics, and perhaps the DNS can be just about domain names for humans. Perhaps we can take all the other stuff that is being shoehorned into the side of the DNS and move it away and give it another way of working. And maybe the idea of resolverless DNS is not actually heresy. It's not actually evil. Maybe this is actually the thing that saves the DNS. That's it. Joanna, you're muted. Somebody had to say that at least once.
Great presentation, Joe. I really enjoyed it. Just a couple of comments from the chat. So Jeff Houston was saying that Paul's DNS Wars talk is the only tech talk I've ever heard that started off by describing the 1648 peace of Westphalia. How he managed to equate that with the DNS was a work of art. I'll give people a few more minutes to pop questions in the Q&A, but in the meantime, I might throw a question on you. And I also particularly like your story about how your daughter had been was surprised that you knew about Telegram.
Yeah, imagine that. Imagine me knowing something.
Well, it's a little bit like my father, who worked in disaster mitigation for many years. I tried to get him onto the internet, and he said, no, it's not for me, and it's my work is so niche, and it's not something I use the internet for. And then a few years later, he called me up and said, I discovered this wonderful thing called the internet. Have you heard about it? And I said, yes, I work in it. But of course, he ignored that and went on and explained how fantastic the internet was for me. But so to go back to, you know, what you were saying about names and DNS, and I mean, really, so names, the reason we came up with names was because we needed like a UI really to the internet. We couldn't remember IP addresses, and we needed to have something that humans could actually interact with and understand. But so why can't robots just use addresses instead?
That's a good question. And I remember suggesting this once when resolverless DNS crossed the boundaries into a DNS group before they got thoroughly flamed at the ITF, before they got thoroughly flamed and ran away. I asked the question and said, well, you know, if you control the client and you control the server, and you get the ability to modulate all the content that goes down, including all the metadata and the links that go along with it, then why couldn't you just send addresses down there as well? And part of the answer to that is that's not how we do it. Part of the answer is that we have this layer of indirection for a reason. We have names for a reason, and resources are most usefully used with names. And there's a lot of dependency on names outside just the transport sending packets. And the last thing is you don't always know what address these things look like, because you are maybe way back in a server farm, several layers of address translation and load balancer from the point where the packets actually hit the wire and are sent back to the client. You don't necessarily always know where those things are. So having this layer of indirection is still useful. It's just that in this particular case, a lot of those names, these ephemeral, short-lived names, don't actually need to be cached. They're often uniquely named because they shouldn't be cached, but they end up being cached anyway, and they cause collateral damage.
And also, so I see a comment from Jeff Houston that because we've run out of addresses, the internet's actually a name-based network, not an address-based network these days. Any other questions from the audience? I'll throw another one in. Oh, let me see, something popped up. So Ivan Beveridge asked, do you feel that resolverless DNS will make security issues, DDoS, viruses, worms, impossible to control?
Well, I'm loath to suggest that anything is impossible because I haven't found anything yet that's impossible, I suppose. I don't know. Maybe I have. I don't think these things are impossible to control. You have to always remember, I think, that when you have malware that's deployed, you're in a similar situation where you have an application and network resources that have been written for each other. They complement each other. There's no reason why a piece of malware needs to use the DNS. A piece of malware can already use HTTPS in order to do name resolution. There's nothing new. I mean, the wars that were going on around DOH were more about these things being turned on by default than the fact that they might exist as possibilities for people to use. So no, I don't think it will make security issues impossible. I think it might be a different set of challenges. I think the risk analysis will be different. But I think you have to look at it in another way as well, which is that when you're inside the TLS bundle that's already been stood up between an application and its resources on the network, you've already done, presumably, sufficient authentication and admission control that it's safe to be able to actually transfer data between them. And that data can include private information, all kinds of sensitive information. So in a way, it's kind of the most narrow security perimeter you can imagine to use that for name lookups as well, because then you're definitively getting something that hasn't been modulated through registries, registrars, resellers. It hasn't been hijacked. It's a name that perhaps doesn't even exist in the DNS because it's effectively a private namespace because it only needs to exist within the context of those channels. So I think there are going to be challenges in trying to learn how to operate these things. But no, I don't see any sort of insurmountable security issues that we don't already have.
Thanks for that. I'll throw in another question. I'll give the audience some time to think up another one. So I thought it was interesting what you were saying about all the domain names used by robots. But so if we remove all the domain names used by robots from the DNS, does that mean that there are more domain names left for humans?
Well, I mean, it's possible, I suppose. I mean, the domain names that are used by robots tend to be domain names that humans don't want to use. If you look under the covers on Facebook and see what the queries are all anchored in which domain names, they're not facebook.com. When you look at CDNs, a lot of the domain names that are being used are not the name of the content provider or the name of the content. They're different names. So I don't know that we expect to see fewer of these names available, or fewer of these names being used by robots, and have that imply that more names are available for people, because I think the same semantic meaning around names for people will still be a problem. You still have names that are harder to get some TLDs than others.
You'd think so. Then again, my local carpooling sharing company is called m.co. So, but you know.
Yeah, it's like trying to Google for that sort of, 80s band, you can't Google for that. So, yeah.
And so if you were to move all the robot names out of the DNS, how would that affect things like security? What about DNSSEC?
Well, I think it makes DNSSEC easier, because I think when you have a naming system that's dependent on these response time synthetic answers that are generated specifically for particular clients, those things are hard. You've only got a certain number of milliseconds to be able to do all those lookups and build a response to send back. And if you need extra time to be able to generate an on-the-fly signature over that, that's more time you don't have. And remember, all of these companies are being compared with each other based on round trip time. So you add another 10 milliseconds to generate a signature. Even if you do it at speed and you do it at scale, it's still extra time. So I think, in a way, what I said at the end about taking the DNS back to its roots, is it goes for DNSSEC too, because I think when you have largely static domains, when what you're publishing in the DNS is the entry point for an application, and when the application starts up and once it's running, it uses a different set of names or names in a different context within that TLS bundle, then I think you end up with an infrastructure that's more stable and easier to sign. So it ought to mean that there could be more DNSSEC. There's certainly fewer reasons not to sign things.
All right, I think the final question from Dinesh Babuta is, we find there's a lack of good domains to choose from for personal use. Does this actually mean more new TLDs need to be introduced in the market, or is there no need?
Well, as somebody who works in the domain name industry, I feel like it's my job to say, yes, of course, we need as much competition as possible, or something, I don't know. I'm sure there's a good business answer to this. But I mean, I think the thing to understand, Dinesh, is that you're actually not normal. You may have heard that before. I say that because we're friends.
Not representative is the word, I think.
Because most people don't do this. Most people are quite happy with Gmail addresses and Yahoo addresses for their email. Most people don't have personal content that's published at domain names. This is not usually a personal thing. So on the one hand, I think, if there aren't as many of them, I think that's not a particularly widespread problem. But also that there are an awful lot of TLDs that have very few names in them these days. So I'm guessing you could find something.
Mm-hmm.
Was that the last question, or did you get to hear from Jeff?
From Jeff, yeah, a huge, great to see as well that, we've got New Zealand, participants from New Zealand calling in, and Jeff from Canberra in Australia as well. A huge amount of DNS engineering has gone into managing local caches to get the DNS responding extremely quickly. In your view, to what extent is the DNS infrastructure incredibly over-engineered?
I think the DNS infrastructure is overbuilt for many of the reasons that I've described. And part of that is the nature of the DNS itself. And the talk was mainly about namespaces and not the DNS protocol. The DNS protocol is not especially easy to build capacity for, because you have to build for the highest spike you might ever experience, which means the biggest DDoS that might ever be launched against you or that you might be collateral damage of. So in terms of capacity building, the whole thing is necessarily overbuilt because of the protocol. I think as far as caches go, I think any amount of overbuilding we could do, and any amount of overbuilding that does happen is quite possibly inadequate, no matter how much we build. And I think the reason for that is that we're using the DNS increasingly for things that this caching system is not suited for. We've got names that fundamentally don't want to be cached, but the mechanism by which they're transferred involves caches, and that's why we have this waste.
Okay, yeah, great questions and great answers as well, Joe. I think with that we will wrap it up. I see that yeah, there was a great discussion. So we've gone a little bit over time, but we run the internet, so we can use as much time as we want. So thank you very much, Joe. It's been a real pleasure to listen to your presentation. We're very honored to have you as part of our LINX Distinguished Speakers series. And thank you everyone who participated.